Okay, getting ready for the big test tomorrow. And one of the main things you have to understand is inverses. So let's talk about what's the inverse to this. X plus 1 over x minus 4. That is going to be called f of x. We want to figure out its inverse, which we will probably call g of x, but we wouldn't have to. Remember that the test writers oftentimes use this notation. That means inverse. So they'd ask you to find f negative 1 of x. That means find the inverse of it. All right, hopefully by now you've learned that you start by saying y equals, and then you flip-flop the x and the y. X equals y plus 1 over y minus 4. And a remarkably scary number of people can't solve that for y. Give it a shot. See if you're one of the people that can. Good question. For right now, just find the inverse, but eventually I will be asking the domain and range, so go ahead. You're done. All right, for those of you that were stumped, you're trying to get y alone. The first thing you got to do is get rid of the fraction. If there isn't a fraction anymore, it'll be way easier. So I'm going to take y minus 4 here and y minus 4 here. And this will cancel. And now that's better because there's no fraction anymore. And now I'll multiply it all out. xy minus 4x equals y plus 1. Keep asking yourself, what am I trying to do here again? Get y alone. Okay, so I got to get y alone. There's two of them. If there's two of them, you got to get them both together before you can get it down to only one of them. So I got to get this y over to the other side. So I'm going to subtract y on both sides. xy minus y minus 4x equals 1. And now I have to get the y's clumped together, so I really don't need these x's over here at all. Get them over there. xy minus y equals positive 4x plus 1. How many of you got it that far? Cool. Anybody stumped right here? Usually there's a few people. Okay, who's got it? What do I do? Yes, sir. Perfect. Y comes out, and what do you get? X minus 1. Good. 4x plus 1. And then, why is that better than this? Because this had two y's in it, and this one's only got one y. The y's alone. So now I can just divide by x minus 1. And then I have y equals 4x plus 1 over x minus 1. There we go. And that is a inverse. Thank you. All right, so now, what's its domain and range? Don't even think about finding the domain and range by looking at this. Find the domain and range by looking at this one. Domain, range. This guy's domain, everything works except x can't be what? Can't be 4. And remember, that comes from the bottom. You set the bottom equal to 0. The range of this thing. The range is harder. You got to think about y stuff, right? So what do you know about y? Bob knows y. Is it bigger on bottom, bigger on top, or same on both? Same on both. And if it's same on both, use a ratio of the lead coefficients, which is 1 and a 1, until it's y equals 1. All reals except y can't be 1. Why can't y be 1? Because it's an asymptote. All right. How many of you get how I got those? Good. Then all I got to do is flip-flop them to get the domain and range of my inverse. So that inverse that's down there somewhere, its domain and range are going to be, well, the domain is this. All reals except, I better not say y, I better say x can't be 1. And the range is from the domain. And that's all reals except y can't be 4. All right. Any questions on those? Yes. Yep. To get if it's same on both, you want to find the lead coefficients. The lead coefficient is just the number that's in front of the variable that is the biggest degree. So this has the degree of 1, this has the degree of 1, so these are the ones that I choose, and I divide those two together to get that ratio. So that's how I knew y equals 1 was an asymptote, because I knew that it was same on both, and that tells me it's a ratio of these guys. Okay? Is that good enough? All right. Okay, so now, what's another kind of question you have? Well, some of them are as simple as what's the domain of this? That'd be like an R2 question. What's the domain of that? Well, that one doesn't have a denominator, but has a square root. What do you know about square roots? They have to be set greater than or equal to 0. So you'd say x squared plus 3x plus 2 is greater than or equal to 0. Solve that one once. I bet you 1/3 of the class will make a dumb mistake. I think most of you probably know to factor it. You go x and plus 1 and plus 2. Oh, that's not that complicated. So the answers are x equals negative 1 and x equals negative 2. Kind of right. Is there more to it? What's the more to it part? This thing right here is telling me to make a what? A number line. Remember how it looks like the end of a number line? It's the pointy on the end of the number line. Okay, so that's telling me make a number line and put on -2 and -1, and then do they work? Well, will they crash this function? No, they'll make it equal what? 0, and it can be 0. It's greater than or equal to 0, so it can be 0. So they don't crash it. How about if I try things like 0? If I put in a 0, is it going to crash my function? No, because I put in a 0, it's going to just make it be square root of 2, and that's okay. So that works. And I'm guessing that things like -3 and -4, and it's true, if you test them, you'll find that they work too. What won't work is something between -1 and -2, like -1.5. It's kind of a pain in the neck to test, but you'll find that it wouldn't work. Okay, so bottom line is it works there to there, so my final answer would be that my domain on this is from -infinity up until -2 it works. And then it starts working again, -1, and goes to infinity. Okay, so there's a domain question. It looked pretty simple, and it was a little more complicated maybe than you might have thought. So you set whatever's under here greater than or equal to 0. Okay, next thing. What if you've got two little functions like x plus 3 and x squared minus 7? So this is f of x, and this is g of x. Remember the ones where we just simply added them together? What's f plus x? Or f plus g? Well, then you just take this plus this. X squared minus 7 plus x plus 3. And then simplify what you can, and that can go together. So I could say x squared plus x minus, what's the 4? There we go. So there's the combined function, f plus g. Do you remember how to find its domain? You just take the two parents' domains and overlap them. Remember that? So what's the domain of this puppy? All reals. What's the domain of that puppy? All reals. So if you overlap all reals and all reals, of course, the answer is all reals. All right. What's the one I told you had a little catch to it? Like you got to overlap 3 things. Divide. All right. So let's do g of x divided by f of x. The way they'd probably write that is g over f. I'd like you to find g over f of x. That's not hard. But find its domain. There's 3 number lines that have to overlap. So that's x squared minus 7 over x plus 3. That's it. Nothing more. Nothing super complicated there. But then the range, or sorry, the domain the parent ones overlapped, plus one more thing. Plus, okay, the two parents are all reals and all reals. But the third number line is that this function that's on the bottom, the f function right here, can't be allowed to be what? It can't be allowed to be 0, so what would make it be 0? -3. So I say -3 is a problem. Everything else works. When you overlap all reals with anything else, the answer is the other thing. So the final answer is this one. So I would say its domain is all reals except x cannot be -3. Or you could say -infinity to -3, union with -3 to infinity. You get that kind. All right. One more kind that's important. F of g of x. So let's have two new functions. F of x. X got weird. F of x is x squared, and g of x is equal to square root of x minus 3. All right? And I'd like you to figure out what f of g of x is and its domain. Domain of f of g. Give it a shot. Okay, so I'm going to put the g function into the f function. So this guy is going to go into this guy. And so I'm going to pick an empty spot squared and then pop in square root of x minus 3. A lot of people ask me, will that squared and that square root cancel? Yes, they will. And what do you get? X minus 3. There is my answer. Now, this is a really good time to remind you that you can't just look at this to figure out the domain, because then you just say that it's all real numbers. Okay? To find this guy's domain, you have to look at two number lines overlapped. The first one is the domain of the inside, d of g, domain of the inside function. Well, what was this one's domain right here? Well, x minus 3 had to be bigger than or equal to 0, so x has to be greater than or equal to 3. Okay? So then, here is greater than or equal to 3. All right. How about the other thing? The other thing is the domain of this new function. The domain of the composite. I'm going to say d of c. That's the new one. Or d of new would also be fine. And what is that domain? All reals. So what is the final answer when you overlap those two? Greater than 3. Or greater than or equal to 3. Go. Bracket. Because it can be 3. Any questions on that kind? Yes. Okay, I'm a dividing kind. I'm going to go back a screen to find that. There's a dividing kind, okay. Yep, so this is domain of f, domain of g. The third one is the domain where the bottom one, which is f of x, so d of f can't be 0. Because get how if it's 0 down there, I'd have a problem? So you figure out what would make f of x be 0. And I look at this and I say, what would make that be 0? And it would be -3 would make it 0. All right. Yes? For multiplication, you don't have to worry about, they're just simpler. For multiplying, add, subtract, and multiply. You just have to overlap the two parents. That's it. You don't have to worry about, because see, if you add, subtract, or multiply, you never have one of the functions on the bottom. See what I mean? So that's why this is the only kind where you have to worry about what if that function becomes 0, because the other ones are adding or subtracting or multiplying, and you never have any function on the bottom. Okay. So the add, subtract, multiply ones are easy. The divide one has that extra third number line. The inside like functions that are inside functions, then you've got two number lines. The inside one has a number line, and the new function you made gets a number line, and you overlap those two, the domains. Okay, so that's just a quick reminder of that part of the lesson. Next thing we learned was about finding inverses and then checking to see if there really are inverses. Now, when we did these two, no, we didn't do those two. We found these two for inverses. We had this one. Oh, that'd be a really nasty one. These are too hard. I want to do an inverse checking one where you see if f of g of x is equal to g of f of x is equal to x. Remember that kind? Make yourself a chart like this. And I'll tell you what the two functions are that I want you to check. I'm going to say 2x plus 3 is one of the functions. And the other one's g of x, and that is x minus 3 over 2. This is going to be a fairly easy one because it won't have the big fractions and fractions and stuff. All right, so g goes into f, so this one goes into this one. See if you can do it. You'll know if you're right, because if your answers come out to x here, and the x here, and this of course has to be x, you just bring x down. Then x equals x equals x means you did it right. And therefore they are functions if it comes out that way. Did it come out that way? Okay, good. Let me double check for you. Here, what could you cancel first? And if you canceled the -3 and the +3 like this, I would mark it wrong, unfortunately. Do you know why you can't do that? Because multiply comes before add. I've got to do this multiplication here first. And the 2 and the divide by 2 would cancel. So x minus 3 plus 3 is my show my work part. You may not just jump to the answer of x. Okay, and just going cross off, answers x, that doesn't count. Because I got to know whether you know what order they cancel in. I know that's harsh, but I'm telling you, all you got to do is show me your work. It's not that hard. All right, and the next one is f goes into g, so this goes into this empty spot -3 over 2, and I drop in 2x plus 3, and then what would cancel first here? You do the top part first, and that the 3 and the -3 would cancel, so you'd have 2x over 2, and then the 2's can cancel. And you get x. So it's x and x and x. It works, and they are inverses. Yes. It's a good question. We will not ask you if two things are inverses. We will say prove that they are inverses. So they will come out to x. So that's the problem. Exactly. The point is not having x and x and x. The point is not writing down these, because I already tested you on that in a different way with f of g of x and different problems. It's just this part right here. It's just to show your work. You have to show your work part right. Yes. Yes, there is, and I'm going to do one more like that with you. One more topic to talk about is fractions in fractions. But before we get to that, do you remember this kind of thing? And I'd ask, is that a function or not? Okay, and that's easy. It's just, does it pass the vertical line test? So is it a function or not? Yes, it is. Okay, because it passes the vertical line test. What about this one? Is this a function or not? Yes, it is, because it passes the vertical line test. But there's another line test, the horizontal line test. So let's look at that one for a second. If I make a line that is a horizontal line like that, ooh, it gets tilty. Undo. Try again. There. So that, does it pass the horizontal line test? No, it fails. So therefore, well, here's the important part. What you're checking for on this is whether or not its inverse will what? Will it be a function? Yes. So bottom line, does this one have an inverse? That's a trick question. Yes, it has an inverse. Everything has an inverse. But is its inverse a function? No. Okay. What happens if it is? Then it's a special kind of function called something. One-to-one. Very good. So here's an example of one. Do you get how that passes the vertical line test? Yes, so it's a function. How about does it pass the horizontal line test? Yeah, it only touches once whenever I do this. Okay, so then it's therefore a special kind of function called a one-to-one function. And its inverse will what? Will be a function. Okay, so there's a simple, is this a function or not? And then there's a, is it a one-to-one function? Which is, yes, because it passes the vertical and horizontal line test. All right, next kind. If you were asked to find the inverse of this, it gets a little hairier. And that's what you have to be able to handle is complicated fractions and fractions stuff. So this is a function. I want you to find me its inverse. And then we'll do the whole test if its inverse is really its inverse, or prove that its inverse is really its inverse. But first of all, for right now, just find its inverse. So you flip-flop the x and the y. X equals y plus 1 over y minus 4. Got to get the fraction out of it. Y minus 4. Y minus 4. Cancels. Xy minus 4x equals y plus 1. Going just like this before. There's the moment where you need the important maneuver of factoring out the y. And then you divide by x minus 1. And then you get your final answer. Y equals 4x plus 1 over x minus 1. Whew. All right, so that's its inverse. Now let's prove that it's its inverse. And that would be the kind that would have the fractions in the fractions. All right. So this is a function. And this original one is a function. And this one I'm going to call g of x. I want you know they're functions. We just showed that they're functions, but you got to prove that they're functions. And it'll end up with fractions in fractions. See if you can handle it. You got to start like that. In fact, I think they're even going to give you the formula, so you don't have to like worry about forgetting the formula. But you have to write it down, draw the lines, keep yourself organized. And now we go. G goes into F. This one's G. This goes into this one. So I need an empty spot plus 1 or empty spot minus 4. And that's going to be 4x plus 1 over x minus 1. 4x plus 1 over x minus 1. And this will test the part whether you know how to make common denominators or not. I'm going to put this over 1 so that they both are fractions at least. Now you got to look at it and say, what's a good denominator for these guys? X minus 1. So if I want an x minus 1 down here, undo just a second because that looks messy with those circles like this. Okay, so if I want an x minus 1 down here and an x minus 1 here, that's okay then. you can do that if you multiply by that, because that's like timesing by 1. Same on the bottom. Now here's the mind-blowing part. You have to look at all of that and simplify it down to something fairly simple. And that goes on the top. If you can't handle it right now, you won't be able to handle it tomorrow. You're really not going to get that much smarter between now and tomorrow. Okay, so try it. If you don't know how to do it, I'll show you. That could be a way to get smarter. I got 2 fractions inside a big fraction. So right now I'm doing the top part of this and the bottom part of this go here. And the bottom part's x minus 1 because they have a common denominator. The top part, 4x plus 1. And then this is 1 times x minus 1. So that's basically just x minus 1. 4x and the x, these guys together, make 5x. Plus 1 and the minus 1, cancel. There we go. That made it cleaner. On the bottom right here, that's going to go right there. Okay, so that's a 4x and a minus 4x, and they'll cancel. A positive 1 and a, well, what's this? Negative 4 times negative 1. Positive 4. Positive 4 and positive 1 makes positive 5. On the bottom, what's right here? On here, it's going to go right here. X minus 1. And then I've got done with my adding common denominators deal. Now I got to do a fraction and a fraction deal. If this had been like 2/3 over 4/5, do you get you'd go 2/3 times 5/4 instead? You get that? Okay, so then I'm going to flip these fractions and multiply. Don't both of them flip. The first one does not flip. The bottom one flips. Only this one flips. Okay, and now, last part is a lot of kids just blindly multiply them all out. It's way better to look for something that'll cancel. See that? And now it's just 5x over 5. And now what? Cancels, and the answer is x. That's what we wanted it to be. Long, painful, but at least you know, on this kind of problem, at least you know the answer's got to come out to x. And if it isn't coming out to x, try it again. You may make a mistake in there somewhere because it's going to come out to x. We're not going to ask you to prove something that's not true. Yes? Yes, hold on. The top of the bottom is this one, yes? Good question. You got to look at each piece and see if it's already been multiplied all out. This part right here is done. There's nothing more to do with it. You know what I mean? It's just a 4x and it's a 1 and it's not getting multiplied by anything, or you know what I mean? But this part is actually a little multiply problem, so I really should multiply that out. Okay, so if I were to expand this over here, I'd say it's 4x plus 1. Those are already done. And then the other part is negative 4 times x, which makes negative 4x, and negative 4 times negative 1. I'm doing that part there. And that's plus 4. And that's why this and this would cancel. And you'd have a 5 and we're done. Okay? Yes? All right. So this last part, do you get that this is a fraction over a fraction? Okay. And when you have a fraction over a fraction, you keep the top fraction the same, and the bottom fraction you flip and multiply. I'll go back to this simple example again. If I had a fraction over a fraction like this, I could change it to 1/2. Do you agree that that means divided by 4/5? But I want to make it a times problem, so I can change that to 1/2. Instead of divided by 4/5, I can say times 5/4. See what I'm doing here? That's what I did to this And so the top one stays the same and the bottom one flips over and multiplies. So top one stays the same, bottom one changes to a multiply by and x minus 1 over 5. See how that's a flip of that? That's what I was doing. And from there, this just canceled this, and then the 5 cancels the 5, and I have x. But I shouldn't do it in one step like that. I wouldn't give you credit for that. I'd just say you have to go, okay, those cancel, and you have 5x over 5. And then you can show me that those cancel. Okay. A lot to know for this test, huh? And it's not like it's impossible. Each piece isn't that hard, but there's a lot of little pieces. Told you that at the beginning. Now, the question is, are you going to study tonight? And it's up to you. I don't have to. I don't have to answer right now. Truth will come tonight. And I'm giving you a worksheet here. Of course, I would do this worksheet, and of course, I would check it. No brainer. I would also look at my old worksheets for the last couple days, and I'd make sure I check them too. Okay. Now, normally, I'm not available for help on Wednesdays, but I found out that tomorrow I can meet with you from 7 to 7:30. So anybody who wants to come in for morning help, 7 to 7:30, you can have a half an hour help, but there'll be other kids here. It won't just be you. So make sure you don't say, oh, I'm just going to come in the morning. That'll fix my test problem. No, you got to study tonight, and if you got a couple questions still, come in. All right, so here is the worksheet. Let's do one together, and I'll keep the recording going so that you can, kids that are doing these at home can get help for the first problem. Yes? I don't think so. I think he actually has a meeting. I just don't. Could you hand these over, please? All right. Numero uno. It says 2x minus 3 over x plus 1. And then it says, find its inverse and identify the domain and range of both the function and the inverse. All right. Let's just do the domain and range part first. Domain, range. The other domain, the other range. How do I say the other one? Well, this is the domain of this function. And this is the domain of f negative 1. And f negative 1, the inverses. Okay, so it's just domain and range. You don't even need to know the inverse for this. You look at the original one and do its domain and range. All right, so what's the domain on that? All reals except not equal negative 1. Okay, how about the range? It's a y thing, yes. And who tells us about the y stuff? Bob. Is this bigger on bottom, bigger on top, or same on both? Same on both, so it's a y equals ratio 2 over 1, y equals 2. All reals except, why can't it be 2? Because that's a what? It's an asymptote. All right, good. And then I know you can flip-flop these, so the domain will become the range, and the range will become the domain. Just make sure you don't say domains are y things. Domains are x things. And ranges are y things. So change the x's to y, so the x's. All right, and then you find the inverse of this puppy. This one's inverse. You start with y equals, then you change it to x equals 2y minus 3 over y plus 1, and it's one of those deals. Got to multiply by y plus 1 on top, or on the left and on the right. That makes these cancel. xy plus x equals 2y minus 3. I got y's on both sides. Make you get this one over here. I think from there you should be able to handle it. We did one like that in class. All right. And on the back side, look at 4a and b. These are fairly simple. Are these functions, which it says they're functions, are they one-to-one functions? Well, then what you really should be asking yourself is about that horizontal line test. All right. A lot of problems on here you can practice. Test is tomorrow. Make sure you study. This one will not be an easy one. It will not be the hardest one you ever have, but it will not be an easy one. Okay? And it's mostly hard because of this algebra stuff. If you cannot add things without common denominators, like you got to get a common denominator and you get stuck, you need to learn to get common denominators. You need to be able to handle fractions and fractions. That's the kind of stuff that kills people on stuff.